Welcome back to Nick Does Maths. It's been a long summer without any fun maths to do, but we are back and we are going to get cracking for this new year. We are going to delve into the realm of MAT style questions. We've got those Oxbridge entrance tests coming up. Let's get ready. So here we have a lovely bit of a geometry question. Now what's key to remember through all of this is that the MAT is broadly designed not to need further maths at all. So while the questions could seem tricky, we know that we don't need to delve too deep into the realm of advanced maths. So what do we have? We've got a circle, radius 1, center 1, 1, and we've drawn a tangent here, both at point Q, wherever it is. And what we know is that the line RQP with the y-intercept and the x-intercept makes an angle theta with the positive x-axis. Okay, cool. We've also labelled this area here A theta, and this area up there B theta, that is for later. We need to find the coordinates of Q in terms of theta and the gradient of the line PQR. So let's start with that. Well, what we might want here is a little bit of geometry because, in fact, if I was to draw this triangle, we can see that that is a right angle, okay? And up here, we have a right angle. The radius is perpendicular to the tangent. Nice little fact in geometry. This line is perpendicular to that one. This line is perpendicular to that one. So the two blue lines are perpendicular to the two black lines. Therefore, they have the same angle between them. Theta there. Now we also know that the radius of this circle is 1. So that actually does tell me that that length there is sine theta and that length there is cos theta. And we are where we want to be. Because that tells me, therefore, that to get to Q, I go to 1, 1. I go along sine theta horizontally, so 1 plus sine theta, and I go up cos theta. And we're up and running. Wicked. Now let's find the gradient. Now we could try and find the coordinates of that point and find the coordinate of that one and find the gradient, but I suggest something else. How about we find the gradient of my blue tangent? The gradient of the blue tangent, change in y over change in x. And that blue radius is perpendicular, so the gradient of PQR is the negative reciprocal minus sine theta over cos theta, which is negative tan theta. So we're on our way. Now we know the coordinates of Q, we know the gradient of the line. Let's find the equation of that line. Not in blue, not you blue. Sit down. Thank you. Right, y minus 1 plus cos theta is minus, and actually I'm going to write this as sine theta over cos theta. I feel like I'm going to want to. X minus 1 minus cos theta. So that is the equation. I'm not going to muck about with that. I'm not going to do anything fancy with it. Might be able to do some stuff with it, but I'm going to leave it as is for now. We want the coordinates of P. Well, at P, y is 0. So we end up with minus 1 minus cos theta is minus or negative x minus 1 minus cos theta. Now we're going to multiply things up. I've got minuses all over the place. Let's multiply everything up. Cos theta plus cos squared theta, multiply this out, is equal to sine theta Yep, that's fine. Sine theta x minus sine theta. That should be a sine theta here, of course. There we go. How many of you caught that before I did? Bum, 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 bum. That minus is gone. We've got rid of it. So that will be a minus sine squared theta. We'll bring it all together and we end up with cos theta plus sine theta. Now I get a cos squared plus sine squared to get plus 1 equals sine theta x. So we end up with x is cot theta plus 1 plus cosec theta. Nice. Right, now, why is this area here equal to that area, except I've got pi over 2 minus theta? Well, it's actually fairly obvious once you realize that this angle up there is pi over 2 minus theta, right? So if we reflect the whole thing in the line y equals x, if we reflect the whole thing in the line y equals x, my a of theta goes up here, my b of theta comes down here, but then that is b of pi over 2 minus theta, and that will equal to a of theta. So just picture yourself reflecting this thing, all right? Then your a becomes your b becomes your a, your theta becomes your pi over 2, and you are up and running. Okay, so it's all just about, think of the reflection here. All right? So essentially what we're saying is we replace theta with pi over 2 minus theta, and we're up and running. Right, what is a of pi over 4? Now we could do this in a general sense, but pi over 4 is quite nice, because when we've got pi over 4, right, if theta equals pi over 4, then a of pi over 4, and we can see from what we just spoke about, is equal to b of pi over 4. Those two areas are equal by symmetry. So that's quite nice. So all we're really left to do is, how about we have a little think about what's going on down here. All right, so what's going on down here? Right, so what is that little area down there? Well, that little area down there is going to be, we've got a square, length 1, so it's going to be 1. Take away the circle, that is a quarter circle, which is pi over 4, it's radius 1. Okay, so that little red area is there. So, what can we say? We can also look at, what are the coordinates of P? Well, the coordinates of P, we need to put, here we go, pi over 4 into here. So the coordinates of P are, cot of pi over 4 is 1, plus 1 is 2. Cosec of pi over 4 is root 2. So we're at 2 plus root 2, 0. And r is at 0, 2 plus root 2, by that symmetry. Okay, love symmetry. Love it. So the area is now going to be the triangle, half base times height is equal to a theta plus b theta, but we've established they're just the same things. That's 2 times a theta, plus my little red bit, plus the circle. And now we just need to tidy this up. 2 plus root 2 all squared is 6 plus 4 root 2, so that is 3 plus 2 root 2 is equal to 2a, probably should have put pi over 4 in there, plus 1 plus 3 pi over 4. And we tidy that up to get the fact that a of pi over 4 is take away 1, divide by 2, so it's 1 plus root 2 minus 3 pi over 8. Awesome. Right, we're going to do this slightly differently in a second. Do this slightly differently. Because our last one is we need to do a of pi over 3, and this might be worth investigating things a little bit differently. Right? Now we could do this in a general sense, but you'll quickly get the idea. So we're at pi over 3. What we are going to do, if I go over to this side here, we are going to split this thing in 2. And that is pi over 6. That is also pi over 6, and this is a right angle triangle. Okay? Little bit of Pythagoras tells me that this is cot. I say Pythagoras, SOHCAHTOA even, that is cot of pi over 6 there. And we also know that this is going to be pi minus pi over 3. All right, these two, we've got two pi over 2 angles there, they're perpendicular. We've got a big quadrilateral here. If we go pong, 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 we've got a nice big quadrilateral. Okay, so we can work from there. And let's create some space up here. Am I going to regret this massively? No, I don't think so. All right. So what are we going to do? We're going to find the area of the triangle. So the area of the triangle is 1/2 base times height, and there are 2 of them. 1, 2. We've got 2 right angle triangles. We are going to take away the sector. So we are going to take away the sector. 1/2 r squared theta 1/2 r squared, and pi minus pi over 3 is 2 pi over 3. And now it's just about tidying this up. 2 times 1/2, that cancels out. Cot of pi over 6 is root 3 minus 1/2 of 2 pi over 3 minus pi over 3. Remember, this is non-calculator, so we are looking out for these values. You might be wondering, why didn't I do that for pi over 4? Well, for pi over 4, I did vaguely consider it, but my problem would have been is I would have had angles of pi over 8, and we don't have, it's not a standard result there, what the values of cot, cos, sine of pi over 8 are. So I had to come up with a different method. Whereas pi over 3, because I was going to end up with pi over 6s, I was all good to go. And there we go. A nice, chill bit of geometry over there in the world of MAT. Nothing to be afraid about. If you enjoyed this and you want to see more of these as they come out over the next few weeks, don't forget to like, subscribe, hit that bell. We're going to have a whole bunch of this content coming out. Go check out the TikTok channel as well. Nick Does Maths. I was Nick. This was Maths. See you next time.